Section 4, Video 3. So what do these things tell us? What can we conclude from this kind of information that we have in these examples? The first one has us being given that CD is perpendicular to AB. So what does that tell us? Well, it tells us that angle CDA is equal to 90 degrees. And also that angle CDB is equal to 90 degrees. And both of those come from the definition of perpendicular lines. Number 2, given that BD bisects angle ABC, what do we conclude? Now we have to read this very carefully so we know exactly what is bisecting what. And it tells us that BD bisects an angle. So BD bisects angle ABC. So it's going towards the angle, ABC, so it cuts this angle in half. Here's your bisector. That means this angle will equal this angle. So we can say that angle ABD is equal to angle CBD. And this is by definition of bisector. Next one, given two intersecting lines, what can we conclude? We can conclude that angle 1 equals angle 2 and angle 3 equals angle 4. And we can tell that from the vertical angle theorem that says that vertical angles are equal in measure. The next one we have given angle 1 and angle 2 are complementary. And if we go by our definition of complementary, we know that angle 1 plus angle 2 equals 90 degrees. And again, as I mentioned, this is the definition of complementary angles. Next one, given BD bisects AC. Again, pay close attention to the order. So BD bisects AC. So here's your bisector. It's going that way and it bisects AC, which tells us that this side and this side are equal in measure. So AD equals CD. And that is definition again of bisector. 6, given E is the midpoint. Well, if you remember, definition of midpoint is middle. It's the middle of AB, which means those two pieces are equal in measure because E is the midpoint. So AE equals BE. And again, definition of midpoint. And given that diagonal AC bisects diagonal BD, what do we conclude? Again, remember, what is bisecting what? Diagonal AC, there's your diagonal, is bisecting BD. So BD is cut in half. So DE is equal to BE. Again, by definition of bisector. So things we can use in our theorems and what we can get from pictures. This ends section 4, video 3.